Hello everyone and welcome to Handmade Hero, the show where we code a complete game live on stream. We are going to try today to actually do some graphics debugging. Yesterday we wanted to do some graphics debugging, but mostly what we did was we worked around two very classic villains in the development world, Windows and graphics drivers. So one of the things that's annoying about programming graphics, one of the things that I think is kind of the worst sort of part of graphics programming that's happened over the past 20 years or so in its evolution is that the actual chips that run the graphics now are not really designed with debuggability in mind. So one of the things that you have to appreciate is an Intel chip, an x64 or something like this, actually has a tremendous amount of engineering in it, specifically for ease of use, basically by developers and by system administrators. It has all sorts of things like the ability to have separated rings of access, the ability to have threads that switch in and out, the ability to put in hardware interrupts that can cause things to happen, and all of these things are designed quite well to allow you to have a good debugging experience and a good virtual machine and process swapping experience, such that you almost never have any problems with multitasking or debugging that are due to a chip, right? It just sort of works, and that's pretty great, actually. GPUs, on the other hand, don't have anything like that. They are not really designed for consistent use in that way. They're getting a little bit better, but they don't really have a coherent, complete, standardized story on things like virtual memory and hardware debugging and ring access and all these other sorts of things. They are trying to do that slowly, and so hopefully, someday we'll get there, but the reality is, if you've been programming with GPUs over the past 10 years or so, you typically have an experience like we had yesterday, where it's just extremely laborious to even get basic rudimentary debugging functionality working, not because there's some kind of extraordinary thing that you're trying to do with respect to that debugging, but literally just like even just stepping through a shader to see what it does is kind of considered a, Herculean task, so that if it actually works, you're flabbergasted that it didn't crash and that it actually ran and didn't do something like RenderDoc did yesterday, where it flames out and can't do anything at all. So we had that problem, and we're using Nsight now, which sort of kind of works. It's extremely slow and error prone, but it sort of works. And then we also ran into a secondary problem when we were trying to use Nsight, which we had not encountered before because this is our first time developing on Windows 10. And apparently we hit what is, I guess, a Windows 10 bug that is absolutely abhorrent. They send OX738 to your window procedure infinitely if you're not careful. This is a kind of a blatantly illegal thing to be doing as far as the API is concerned. That's a WM user range message, which should never be sent to anyone's window. It's only for people to send to their own windows, basically. So we had to debug that yesterday, which was also a whole heap of fun because you're not expecting that to have happened, and that's apparently only on Windows 10. So that's great. But now, in theory, we may finally be able to do some actual development today. And so that's what we're going to try and do. Now, remember, all we really want to do here is see if we can take a look at what's being done in the graphics driver for our light rendering code. And that's, that's really the long and short of it. There's no other fanciness that's trying to happen here. We just want to take a look and see if we can understand anything about the textures we're submitting and what's going on. So I'm going to try to avoid using the graphics debugger still, kind of like we used to be debugging it, where we didn't really use the graphics debugger very much. The reason I'm going to do that is because you saw how janky it was yesterday. So we'll use it when we need it, when we can't figure out another way to test it, but we're going to try and use it lightly. So yeah, I mean, I don't know what to say other than this is why GPU programming sucks, and it would be nice if someday we add a stable GPU experience with development, just like we do on a CPU. And you know, sometimes we take the CPU development experience for granted, and probably we shouldn't, because just a quick attempt to do program debugging on a GPU should remind you just how bad GPUs are at this, and just how good CPUs consistently are with no prodding. You know, like nobody has to beg Intel or AMD to ship a chip that you can debug cleanly. All right, so for starters, I'm tired of this weird like developer news page nonsense coming up, and I believe you can switch that in here. So I'm gonna. Here we go. I like we ever want to download content from Microsoft while we're developing. That's an interesting idea. So I'm going to go ahead and verify that we can just launch our program directly when we open up Visual Studio from now on. Let's see, there it is. So that's much better. So where we left off, we fixed that 0x738 bug that Windows 10 had introduced. Technically what we did is we fixed a bug in Windows 10 in our code. We did not actually have a bug ourselves, but there you go. So when I hit the F1 key, this is recomputing a lighting solution. And I believe this lighting solution is actually somewhat correct. It's not a great lighting solution, but it is actually like a real lighting solution that we computed, and it's not all black. And we can verify that by turning on the old color, using the colors that don't come from the lighting solution. So in here where we do our lighting computation, we use this while loop to look up the lights and so on. What we can do instead of overwriting this use light stuff here, I believe if we just tell it not to overwrite, we would get the old color that was being sent down directly from the engine. And so, yeah, you can kind of see that here. So if I hit F1 to do the lighting computation, you can kind of see that it actually is doing some lighting, meaning, you know, there's some yellow lights here that we're seeing, there's some white light here that we're seeing, and the light probes that are around here, the lighting element points that are doing the reflection, actually do have correct colors. I mean, like I said, we're not doing much in the way of a good lighting solution or anything like that at the moment, but we are actually doing something that resembles lighting. Whereas what we're getting when we actually go into, when we actually try to use that lighting solution, we're getting just blackness. So what we're trying to do now is kind of claw our way back to having this work properly, which currently it is not. So the first thing that I'd like to do is try to figure out whether the Texel fetch stuff is working at all, or whether, you know, there's sort of like two parts of this program that can be broken. The first part of the program that could be broken is the lighting lookup itself. So you can see we've got this kind of weird situation here, and it looks like we're stuffing a value for lookup right now that we thought was one that should have had some light in it. I think that's why we were doing that testing before. If you remember correctly, I forgot that we were doing this exact thing here. If you remember, we looked at this yesterday actually, and I was like, I don't remember why we were doing that. This was the front emit thing, I guess. I'm not sure why we were looking. I guess we were just looking for something where the front emit red was greater than 0.5, something that would have a bright cell in it. This debug X, debug Y, debug Z is probably just what we filled in here. So we were forcing the issue of looking up a light that should have had something in it, right? But instead, this light eye, this is never getting entered. The reason we know that it's never getting entered is that we never get any green at all here. So there's two possible things that could be happening. The first one is that this lookup is busted, and instead of actually looking up into this location like it's supposed to, it's actually just totally wrong. You know? Like maybe it looks up into the wrong place in the texture, or maybe this 65535 plus 0.5 stuff doesn't work, so the cast, like maybe we're not converting it to a light index properly, and so we can't do our texel fetch correctly. You know, who knows, right? We have no idea what's going wrong here, but it could be any of those things. Once we come in here, this part we've taken out of the equation, so we know that this can't be wrong because we're just stuffing the light value with green. So if the light lookup here had succeeded at all, then we would get into this loop and we would see green, right? Of course, the only thing I'm not sure about is we wouldn't get out of the loop. Well, I guess we would, because we'd still be looking it up this way. So I guess that's okay. We could force our way out of the loop if we wanted to. We could break here, right, out of the loop. Or change this to an if, right? So in that sense, we could do it. But anyway, so something in that light lookup could be wrong. And so that's one thing we have to worry about. But there's another thing that we have to worry about, and that is that we're not actually sending down any valid texture data. So we know when we output our cubes, right? When we output those cubes, we know that they had the lighting values that we were expecting to see. What we don't know is whether or not the texture has that property, right? We're trying to send down a 3D texture that will mirror the information that is in those cubes. We don't actually know whether that succeeded. And that's, you know, another whole part of the problem that could be wrong. And so maybe this code is actually correct, or even if it's in error, maybe it doesn't matter that it's in error yet, because we just don't have a valid texture set to look up into. We're packing it wrong. We're sending it down wrong. We're setting it up incorrectly, so the shader can't read from it correctly. All of those things could be wrong. And again, since we can't step through anything or see anything, it's always this nasty problem of like, okay, we've got to start black box debugging it. All right. So let's start by saying, how are we actually putting these things together, right? At the moment, I think what we're doing is we're trying to do, when we output our lighting textures, right? You can see us doing it here. I think this piece right here is pretty much where we're doing all of the packing. I can watch this thing pack by using this if statement we've already got in there, right? So if I go ahead and pong over to that, I thought there's also some way. How do we leave windows pinned? I know there was something about that you can do. Yeah. Floating to us. No. Show pin tabs are a row. Show pin button in unpinned tabs. Maintain pin size down from well. Then it has to be opened in the preview tab. I think that's what we don't want. So anyway, I'm going to take a look in here in output lighting textures. And I'm going to run. And now when I hit F1, I should get in there. I'm going to look to see when we hit this. And I'm going to just to see when we've arrived. I'm going to take a look at what that debug X, debug Y is, and I'm going to watch it pack it. So here's the debug X, debug X. Ah, man, that is just awful. That's another setting it would be nice to fix. Is there a way to make it go to the next line in the watch window? because man, they changed that from the old one, and that just, I have no idea why you would ever change that. It seems nuts, because it's literally just worse. But I don't know. I don't know if they even like realized they changed it. I can't imagine that they did, but maybe. Debugging. General. I don't know what just my code is, but it sounds not good. Oh man, it looks like we're sad. There's nothing on there. God. I really hope one of the Handmade debugger projects gets functional soon. All right, 126, 113, 27. I'm going to take a quick look and make sure that's what it was. Yeah, so you can see exactly what we were doing there, right? We were just trying to take the first voxel that we knew had something in it, and we were going to try and use that. So let's see here. I guess we should really be compiling this in debug mode. But anyway, so in the pnext texture here, and the lookup at texture. All right, let me actually do this in debug mode so we can inspect all our variables. I just want to see if like it looks like we're putting stuff into that location, or whether it's kind of looks a little bogus. I'm not sure which we've done yet because it's been a long time since we've coded. The difference between debug and release for this is pretty dramatic. All right, so here we are. I'm going to take a look at various informations. So the pack index here, the pack index is just which one of these we're actually at, right? We plus it instead of, we plus pack index instead of pack index plus, because we want to leave the 0th element as nothing, because we want to be able to have the idea to specify a null. So light index 0 is like the non-light. So light index 1 would be the first thing we pack. We've packed a great number of these already, 612. This one right here we're packing is number 613. We are asserting that it's within the range of lights that we're allowed to pack, which we did. And so now we're taking a look at the actual element we're going to pack here. So here's pnext. It's got a floating point position of nothing and a next pointer of nothing. And now we're going to specify that the element, which is the actual light we calculated, we're going to specify that the position value is going to take on that of its element, which it does, and that's good. We're going to make the next one be whatever was at the lookup already at this moment, which was nothing. And then we're going to set the lookup equal to our pack index. So now it's basically a singly linked list that points to this element and that does not have any other element in it. Like it doesn't have any other, there's not some other light that needs to go in there. So then we're going to come through. I wonder if, again, we'll have the same one, 129, 113, 27. So I guess not. We're actually... we've moved a little bit. So I wanted to see whether the daisy chaining was working, but it doesn't look like I'll be able to quite that way. I don't really care if the daisy chaining is working yet, to be fair, because it looks like we're having a problem more significant than the daisy chaining. So it doesn't look like it's really that important to debug that part. The dest color part, I'm not sure we really looked at that. What's going on in there? I assume... So we are packing a pretty reasonable value into there as well. So all of this looks, you know, sane to me. I don't see, you know, I don't see a lot of cruft there. So I'm going to come in here to where we do our render element. This is what's going to transfer the lighting actually down. This is the record that flows through to the renderer. And if we look at what we specify here, I want to make sure that we're doing the right thing with respect to sending these textures down. So here's our pNext value that we specified. And I just want to look at like the first 32 values of it, right? And what you can see, I don't know why it's showing me, I guess we declared it as a float. As just a float pointer? I guess we declared this just as a pointer to floating point data, which is probably makes sense because we're probably sending it down that way. But anyway, you can see that it's got reasonable stuff in it. I mean, it's got positions, and then it's got occasional next pointers. It should anyway. If we look down, there should be some floats that look absurd. Of course, they won't be any of the first ones probably. It would probably be more of ones later on. Let me see if that's true. I don't know how many lighting. Yeah. So what you can see here is we're starting to get next values. The reason they're ridiculous floating point values because they're actually integers, right? So if I took this and said instead of, you know, you don't think of it as a float, think of it as an integer, then we can see we get like bogus integers and then real for the position values, and then real integers for the next values, right? The p values are, you know, those are actually float, and these are int. So that's a pointer to the data that we do actually want to submit. That looks like it's correct, you know. So that's good. And then we've got these other ones here, and I'll just take a look at them. There's C is the color channel. And these all look pretty sane. That's an alpha value of 0, and I'm sorry, an alpha value of 1, and the rest is 0. Let me make sure that some of these somewhere have some color value in them. Yes, they do, right? So you can see that those are colors. And so finally, we'll take a look at the lookup. Here's the lookup, and this is just the first, for any given voxel cell, this is the first light that it should use. Not seeing a lot in there. What I might do here is say, all right, let's take a look at how big this guy actually should be, and actually just look at all of it to see whether it's filled out at all. So if we do that, that is in Handmade platform, and we can see the dimensions listed here. I've got a pound defined for them. It's 256 by 256 by 32, and so 256 by 256 by 32. So there's 2 million entries in the voxel, and so I should be able to take a look at memory there. Got to get a memory window back. I should be able to take a look at the memory here. Actually, I think I will leave it down here. And take a look at, it's a little bit behind my head was the only reason I was a little hesitant there. So I believe, well, actually, it's actually a 2-byte integer, right? I think was the way lookup currently works. And so we can just kind of scroll through here. If we want to know what the address would be where we would end, we now know that it's 2 times 2 million, right? So this is the last address of, well, it's one past the last address of our voxel lookup. So what I can do is just say, well, I'm starting at the 110. Let me just scroll through. And I know that until I hit that end point that we're all in the voxel, right? So admittedly not seeing much here, right? We know we have till E, so right now it's DD, and we know we have till E. So, you know, maybe it's just all this stuff is all zeros for most of it. There was one. We should get into some areas that are pretty dense, though. Like one lookup in the entire thing does not seem good. There's some more. I will say it's pretty sparse. I wonder if we messed up our voxel somehow. Because in theory it should be fairly tightly bounded, like we just used. Well, we don't actually know that. There could be some things throwing off our bounds. We should probably look at what the bounds are of the voxel. So I think maybe the right thing to do, just based on looking at this, is just to visualize the voxel maybe, and verify that we're not stuffing anything incorrect in there. It's hard to say because the voxel is so big. I mean, this is the bane of three-dimensionality, right? It's got it's got 2 million entries. It's very hard to think about that and go, well, just looking at this array, does it feel like it's correct? You know? And yeah, I mean, it's really hard to make that a judgment call. So I think it's probably something we'll want to draw out, because I don't think it's reasonable to expect me to be able to guess whether, you know, maybe this really is still correct, because there are entries in it. It's not completely empty. The fact that it's fairly sparse might just mean, well, hey, we're still looking at the beginning part of it. Maybe it gets really dense later in the parts that we expect. But even then, if I see a dense part later, it could be that we're not aligning properly. And so when we go to look it up, it's wrong and blah, 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 right? So yeah, so we've got a lot of issues there, to say the least. All right, so let's think about this here. Let's take a quick look and see if there's anything we can tell about our voxel lookup. And the other thing we could do here is, if we read from the voxel lookup, maybe we can make something that puts cubes out into the voxel lookup that would help us understand what we're actually seeing in there. For example, so one of the things when we hit F1 that we're doing right now, one of the things that we would like to be able to see is, could we get those cubes to show us more about what's going on in the voxel? And when we do output, I guess it's output lighting verts that we're doing. Are we doing output texture debug? Yeah. So when we do output texture debug and we come through here, we're pushing cubes. We are pushing cubes based on what we stored in the voxel. So we know that the voxel's lighting solution is actually all stored in there. What we don't know is that they're actually properly aligned with where the voxel thinks it is. So for example, when we push these cubes on, we are working through what's in the voxel at any particular location, but we don't actually know whether or not that voxel, whether or not the light that's stored in that voxel, the one that has this p-value, we don't know whether it's actually a, whether that p-value is actually contained inside the voxel, right? So for all we know, this could be completely bogus. So what would be nice to do is actually try to translate this out in some way where we figure out whether or not the voxel, whether the things that are in each voxel cell properly correspond to lights in that region. All right. So let's go ahead and see if we can get any information about that. So what we would like to do here is say, okay, let's take a look at this loop here. And let's have two ways that we can do it, right? So the first thing we want to do is instead of actually outputting things at their real location, we're going to output them at the center of the voxel so that we can see where it is. We're still going to do the push cube, but we're going to do it outside. So we need to have a thing here that says like where we should put the element, right? So what I want to do is say if there's anything in this voxel, you know, skip it if there's nothing in it. If there's anything in the voxel, compute like the average color value. Something like this. So we start out with a black color. We sum up all of the colors that there are in there. And then at the end, we'll just divide by however many there were. Right? So this will produce an average value for each voxel cell that has anything in it. And then it will put a cube at that location with that color value. Now, the only thing we don't have here is we don't know where to put this guy because we don't have any way to compute that yet. So what we want to do is we want to get the voxel X, Y, and Z out by using that dimension value. So what we want to do is like, you know, min, you know, voxel min corner plus X times, you know, well, basically this. So whatever the voxel dimension is, we want to multiply that by wherever we are, X, Y, and Z, integer-wise, and we want to offset from the min corner of the voxel. That would put us at the corner of this voxel. We probably want to be at the center of the voxel, so we can also do like an 0.5f times the voxel dimension plus, right? Another way to do that would be to add 0.5 to each of these, but either way. All right. So that's what we need to do. We need to take a look here at where that information is going to be, how that information is going to get to us is the only thing. Because as you can see here where we do lighting solution, solution, and lighting textures, textures, I don't know that we actually store that anywhere. You can see in here, it doesn't look like we actually store that data, unfortunately. So what I might do is say, let's actually put that in there so that when we come through here and we store like min corner, max corner, that crap, let's go ahead and actually keep that in here as well, right? So let's say that we've got a min corner, and a max corner, and a cell dim, and an im cell dim, like so. And that way, when this thing produces the lighting solution, we can actually store these values and have some idea of what they actually are. So I think that's just this. Nothing much to it. And that'll store all those values off so that now we can use them anywhere that we want to. If I come back up here, I should be able to now get this out of the texture set. So there's the voxel min corner, there's the cell dim, and here's cell dim a second time. So that's really it. That's all I wanted to do. And that way I can just kind of see if these things are roughly in the right place. I think we called that V3I or V3U. I thought we had something like that. I guess we only had V2. Uninitialized local variable. Right you are, sir. Thank you, compiler. So now I'm going to run the lighting, and it's going to take a little longer because we are running in debug mode. I could probably go back to 02 if we want to, but probably it's not that long. So this is the lighting solution running now. We are going to do the voxel creation. We don't need to stop here for any particular reason. So yeah, not reassuring, right? I see nothing. But that's kind of good because, I mean, maybe there's a bug in this, but if it turns out that there isn't a bug in this, then that puts us a little bit closer to understanding what our problem is, because if this is actually wording correctly now and we're not getting anything, that's a good indication that our voxel lookup is kind of borked. Let's go ahead and step into that and see what's going on in it. Maybe it just has a bug and we shouldn't get too excited. Or maybe we've actually found something. Only one way to tell. Okay. So the first thing we're going to do is see if we ever get in here. Right, we may never, but we did. So we know that there are some voxels that have indices in them, which we believed already to be the case because when we looked in the memory window and scanned the voxels, it did look like there was stuff happening there. So that's good. When we sum up the color value here, that doesn't look very promising. It looks like the color value is 0, but that's okay. Actually, we should still see a cube. Maybe there just wasn't any light there, so that's actually fine. So now let's take a look at what we're getting in the actual location values. So -35 to 35, the cell dimension. That's totally wrong. Oh, I see. Because we only ever compute inverse cell dimension. This is actually the whole voxel dimension. My bad. Hey, I named it correctly. I just didn't actually do it. So let's go ahead and do cell dim here. And And what you can see is basically we just do the divide the other way around. So this is how much we have to span, and we divide by the lookup value. And there we get the Seldon. So that's fine. Let's try that one more time. So with that bug fixed, it looks like two things. One, it looks like we have correctly stored the voxels where they are, right? I mean, that looks right to me. Two, we should probably run that again to make sure that the color values are right in there. So what I'm going to do here is just go back to the OpenGL path, and where we slam the green in there and do the index loop, I'm going to go ahead and recomment out the value that I'm going to recomment the part where we assign the value over the default light value that comes from the render stream. So yeah, this. So I'm going to let it use the lighting value that it's being told. I'm leaving it as 02 because we're just kind of testing now. We don't need to step through anything. So when I run this, this is viewing these created from the voxels positioning. So it looks like they're placed in the right location as well. So we now can be relatively sure that our prepass is more or less correct. Meaning when we're setting up the texture data, it seems to be correct. So that means we can now move on to step 2 of this process, which is taking a look inside the part where we submit the textures and seeing whether or not when we submit the actual textures, whether we set anything sensible for them or not, right? So, because again, we now know that it looks like the texture data is being prepped properly in memory. What we don't know is whether or not OpenGL ever gets that texture data. So like right here, you can see where we do our submissions, entry P next, entry C, entry lookup. We don't really know whether any of this stuff worked, right? Like we don't know, we have no idea whether any of this stuff got put in properly. It could be completely incorrect, right? So that's the next thing we got to take a look at. We also don't know what order these are stored in. And this is kind of a big deal, I guess. And it looks like I didn't give it much thought when we first put this in here. So maybe I was just in a hurry and didn't have a chance to take a look at it. But if you see here, we've got X, Y, and Z as the 3 indices here. I don't know if that's actually what we're doing, meaning, excuse me. I don't know whether we're storing them that way in the actual voxel writing routine itself. So for example, if you look at what's going on here, we're indexing by X as the least significant factor, Y in the middle, and Z is the most significant factor. I don't know what OpenGL is going to do. I assume it will do it in that order, but we would probably should go look at some documentation to verify that that's actually correct. Right? So when we do these text sub-image calls, I want to take a look to make sure we've defined these textures correctly as well. So if I go back to where we're doing lighting, where we're going back to lighting P next, and I look at these and see how we're storing them. I mean, this looks wrong to me already. if you take a look at how these are being sent, when I say GL text image 1D, I'm saying that I'm passing an unsigned byte, which I suppose doesn't matter because we're not passing any data, but I'm saying that the internal storage format is only 8 bits wide. But we said that our internal storage format was going to be quite different than that. We said it was going to be 16 bytes, correct? So this is not an R8. I mean, this is an R16. This is relatively correct. It's 32F, meaning it's going to be RG and B float. Then the final float, which is actually the next parameter, is going to have to be stored as a float anyway, but we're going to, I guess, convert it out of a float into a different value. We're going to reinterpret it as an integer, which I assume is okay, but we'll cross that bridge when we come to it. So that was not right. I don't know how much of an effect that would have had, but you know, any of those values above 226 would have been getting truncated. So I don't know, that could have been fairly significant. It's probably not the only bug, but it's definitely a bug. So, all right. So we hope that this actually produces the empty space for the textures that we actually need and records their storage format properly, but we don't actually know that, and we don't actually know whether or not any of this data actually got down to them properly. Sadly, I'm not really sure a good way to check to see if it did. I'm going to try inspecting this part maybe in the graphics debugger, and we'll see if it can help us here. What I can do is make sure that the Vox min corner and Vox inv cell dim are set correctly, because those are just values that we can inspect and verify at that set time, as well as when we set them in the shader prep, right? Hello. There we go. All right. So if I go ahead and look at that, actually, let me. So if I go ahead and look at that inside the OpenGL path, I'm going to have to get into OpenGL render commands. What I want to do here is make sure that we're setting like the voxel lookup parameters properly. So I want to step to right. Oops, that's the wrong key. So I want to take a look here and make sure that those two values got set to what we were expecting. So here's the voxel min corner. Here's the voxel inverse cell dim. That looks about right. So if you imagine the math that's going to happen here, we're going to take the min corner and we're going to subtract it away from whatever voxel lookup we have. And we're going to end up with a value that's going to run from like negative 35 to 35. We're going to subtract that 35 from it, again with this 0 to like 60 or 70. And that times 3 is about 256, right? So it does look like this is properly sort of, pushing us in the direction we expect to go. I don't know if we're actually setting those values properly. So that's where I think we could maybe, hopefully, a little bit sort of, kind of, if every Windows and the GPU decide to cooperate with us, we could see perhaps some information from the graphics card to corroborate that, which would be nice. I'm going to go ahead and try that here. I'm not particularly optimistic, but here we go. So I'm going to go to the pause and capture frame. We're going to wait 17 years. And after that 17 years has elapsed, we will hope that maybe we will get some graphics analysis to look at. Okay. So now that we have the graphics analysis, we're going to try to look at these textures. So if we jump into one of the render passes here, you can see like our render target passes. These are our depth peels here, I believe, happening, right? Depth peel 0, 1, 2, 3. If we jump into a random one in the middle of the depth peel or whatever, we should be able to go see the lighting values because they're involved in every render, right? They're set for every render. And we should also be able to see in the fragment shader, we should be able to see the voxel corner and stuff be set. So there they are. And so, hey, that's a nice thing the graphics debugger did for us. That verifies that those values are actually being passed down correctly as we wanted them to be, right? So that's nice. So let's see if we can take it a step further and see whether like our textures here, whether we can get any information about those. I don't really know what this is showing me exactly, but I think it's because it's 256 by, yeah, okay. So since it's 256 by 256 by 32, this is correct. It's showing me the 32 Z levels of this, texture, right? If I take a look at one of them, I would have expected to see something here. Like I'm not seeing any pixels at all, right? Everything appears to be 0. And that's just not good. We know these are 16-bit integers. Let's get something we can see here. We know these are 16-bit integers. I really don't know how to do anything particularly clever here, but well, so there's some. So there, we are sending down something, right? It's not very dense, but again, it wasn't very dense when we looked at it in our memory window either, right? It's because, hey, it's a sparse voxel. It even in, if it's being done correctly, it will not necessarily be particularly dense. If I go back here and look at a graphical representation, I don't know how to actually see this one. Here's the color sampler, for example. I don't know why this only shows white when it actually doesn't show that here. But anyway, here's the color values. And you can see RGBA, RGBA. And again, that looks like what we thought, that looks, I don't see anything particularly unusual there. And same is true for this. I don't really know how to say much about the position when I could look at it as 32-bit floats here. And, those look like valid light positions, certainly. I see literally no next parameters, which is weird. That feels wrong. I don't know if maybe we just never fill our voxel any deeper than that, but it seems like we should have 2. At some point there should be 2 in the same place, but I don't see that ever happening, which is a little bit weird. That may be because you can't send down bogus floats. It may be that we have to switch this to 32-bit. But again, even if that were the case, that as a bug should not actually be causing us any harm because we know that we're not even seeing a first light value anywhere, at least as far as we can tell. Because even if we set all the colors to black and weren't sending any of that down, just if there was even just a lookup hit, if we ever hit the lookup properly even once, we would see green because we're stuffing a green value if the lookup value ever succeeds. So we don't even care about the next pointer. We should be seeing some green somewhere if we were not completely busted. So we know that something is much more busted than just that. Well, hey, the graphics debugger did something useful, right? That's a good thing. We can applaud that. We were able to actually see, some corroboration here that we weren't nuts, and that we were sending down our values properly. So that's good. So we think those are relatively correct. The next pointer, it looks like that's incorrect. So it looks like we will have to send down that mixed mode texture. It looks like we're gonna have to do more work there. We could possibly send that down as part of the other one. Who knows what we could probably do something, but we've got some issues there. So anyway, let's go take a look at that shader. Maybe there's something that we're doing wrong in terms of when we're doing the lookup that we could fix, and see what's going on there. So let's see here. So there's a couple of things on the table, like I was saying before. We don't really know how the indexing is working inside OpenGL when we send down that texture. It could be that we got the indices backwards. I don't really know, because we are assuming that it follows the same convention as XY textures, where the XY values are specified. In the GL text image call, you get XY, but when you're indexing them, you're actually indexing X minor, Y major. We assume that XYZ follows the same rule, meaning that X is still minor, Y is more major, and Z is most major. But we might have to verify that because we don't really know that it's necessarily true. We're just assuming that it's true. But anyway, inside here, if we take a look at what's going on, it seems fairly straightforward. We're taking the world position, which we believe we have correct. It gets passed in from the vertex shader. Directly. So that's an unmolested world position, right? So hopefully we take that unmolested world position there, which includes the Z bias, which is what we want actually, and so that's all fine. We take that unmolested world position, we subtract the Voxman corner from it, we multiply the image itself and get the position, we floor that. That all seems like reasonable work to me. We are currently overwriting the value by looking up into a place where we believe there to be a value already. We're doing a textile fetch into that lookup sampler with that hard-coded address. And, we're grabbing the red value out of there. We're multiplying that red value by 65535 and adding 0.5. I don't know... I don't really know the specifics of how that textile fetch is working. So when you do something like a textile fetch in OpenGL, I always have trouble remembering how you're supposed to tell it that this thing we're looking up into is a 16-bit value, and I don't want you to turn it into a float, right? I'm not sure. Let me take a look at that. Right now what we're doing is it's turning it into a float and we're turning it back. Yeah, so this is... Let me see, we've got two things here, not from particularly great sources, unfortunately. Let's see. This is old. Like, luminance is not still a value, so that's not going to help us. So I guess it's true. I'm not passing UI, which I should. However, yeah, is uSampler available in what we're using right now? Because that I probably should be doing, right? Like that would be better, and I'm not sure whether we've got that or not. I believe we're still set up to error when we have a compilation fail. So I'm assuming that we will hit that. But what I would like to do here is, yeah, like these two we actually want float at least at the moment. But uSampler 3D for this, I think, is what I would ideally like to use. So if you do a uSampler and you do a textile fetch, I wonder if you can get out exactly just the integer there. I can also make sure that inside the OpenGL loop, again, I pass in here, instead of an R16, I wonder if I can do an R16 UI. Hopefully. So if that's the case, OpenGL would then know exactly what I was trying to store there. And maybe I can get a more direct lookup here. So when I fetch this out, it would just be like textile fetch, and I don't know, can I actually do that? OpenGL create program. Yeah, I don't. Why did it break all the way up there? I don't really know. This is probably something I can configure in the new thing or whatever. Anyway, that is what I wanted to have happen. So now I can actually look at the errors. So that's fine. Vertex errors, fragment errors, and program errors. So that's actually good. Implicit class from uint to int. That's great, because that basically means that textile fetch now is producing an unsigned integer, which is fantastic. That's what I wanted. That's what I was hoping for. So let's find out if that flies. Uh, 125. What? We don't look up into the lookup sampler anywhere else, though, do we? I guess right here we're assigning to light I. Is it just that textile fetch wants an actual int, not a uint, all the time? Like it can't use a uint? Kind of looks that way. It also looks like for some reason it's complaining about this. Like I guess 0 is not one of those. So I guess I'll just do this for now. And see how we do. Oh, right, forgot it. forgot that OpenGL has the sort of function style cast. So we got an error. What is the error? Texture type and format combination is not valid. So it didn't like this for whatever reason. So R16 UI, it did not want me to specify, it looks like. So I can't say I know why it would be particularly upset about that, because that looks like the sort of thing that would be relatively straightforward. I mean, all we're doing is saying, hey, you know, we're not even sending down any data. You know, it's just a 0 pointer. So all you have to do, all we're doing is telling it the internal storage format of the texture, which we wanted to be 16-bit unsigned integer. But it doesn't like that. And I'm not sure why. So does that imply that 3D textures for some reason cannot be unsigned integers? Which, I mean, and again, we don't really even necessarily need a 3D texture because we can do our lookups manually. We could, you know, we could easily do this with a non-3D texture, just a bigger 2D texture or something like that. But I'm not sure why it would care what the internal format of the texture was just because it was 3D. It looks maybe more like it doesn't know what that format is. So let's see. Let's see. So inside internal format, this is old news. Let me see if I can get something that says what we should be able to specify there. So interestingly enough, it actually specifically says right here that that's one of the constants that would be allowed. Right? And GL red is also accepted here. Not that we care, because again, we're not really sending anything down. So I don't see anything. So I don't really see what we can do there differently. That looks like something that should work. Unfortunately, they're not giving us enough information to know what it doesn't like about it. It said format and type are not compatible, I believe. And I guess technically that's those two. Unless it means this and this. But they look correctly compatible. Because an R16 UI would in theory be exactly red unsigned short. Right? I mean, that's exactly what you would expect to have there, because that is what an R16 UI is. It's a red unsigned short. So it doesn't seem like it would really be complaining about that. I'm not sure. So strictly out of curiosity, what if I just asked it for an even bigger one? Doesn't like that. How about a floating point one? So it's totally fine with floating point. Floating point's no problem. But it really doesn't want an integer texture, I guess. So I could store a 32-bit float per texture channel in the 3D texture, but I just can't have an unsigned integer of any size at all. So I wonder what happens if it's just signed. Is that also bad? Yep. So it has to be float. Why? I don't understand. What's magic about floating point values that it really wants to store floating point values and really doesn't want to store anything else? Well, I can't say I know what the deal is here or why anyone would care, because we really just want blind texture data. We could change to using some kind of a buffer lookup, I suppose, because we don't really need... we don't really care about the texture aspect of this, right? We're not asking it to texture from it, really, in the way that you would normally do these lookups. But I guess what that means is, all right, if we're going to have to do a float, if we would have to do a float, then we could do a float, right? And that would be fine. We could just have a single 32-bit entry that was a float, and the floating point value we decrypt, right? I mean, we can just store this thing as a floating point value, and that's no big deal. I really just don't understand why integer isn't on the table, because we know that it's already an integer. I mean, like RGB A8 for example, is already an 8-bit integer format, right? We know that it can store textures that way. So I'm not sure why it doesn't really want to store them in some other way, but you know, that's just how it goes, I guess. So if it wants to store them only as float, that's okay. We can do that for now, but it would be nice to know how to convince it not to do that. If we were going to do that, then what we'd have to do is when we look up this value, we'd have to do essentially what we're doing before. We'd have to multiply it by 65536 when we do the textual fetch and make sure to round, right? And so when we go to submit that texture, I don't know if we want to submit it as float as well, just to make sure. But that's the basic idea. So I don't really know why that's going on there. It really doesn't seem like it should have to happen, but there you go. So one thing I would like to know is, can we step into that shader? I don't know if that's asking too much. It probably is, but let me see here. Go ahead and capture. So, all right. If we want to take a look at one of these shader calls, here's the fragment shader. Let me just see if it will let me insert a breakpoint here. It doesn't look like it will, unfortunately. I was hoping we could do something where we could actually take a look at some of the I was going to see if we could take a look at some of the shader code there in action, but that doesn't look likely. Let's see. I have done this before successfully. I just don't remember exactly how I convinced it to work. I do remember it took a little while. Of course, I've never done it in this particular version of Visual Studio or Insight, but let me see. So let me look up, because I really do think you can do this step through shader with Insight, at least under certain circumstances. Here we go. Access the shader debugger. Start debugging your graphics project from Insight, Windows shaders. Okay, there we go. I knew there was a way to do it. It's been a while. There it is. All right. So in theory, let's see here. So in theory, we want program 281, which is this one, right? So there we go. All right. The following table shows the possible states of the symbolic status. Ready. Shader has not been used by the application. No symbols have been loaded. Not a debuggable shader. However, where does that get listed? I don't see any of those things listed anywhere. I don't know why it says debug info none. Shader debugging is not supported for this GPU. Well, I guess that answers that question. I don't know why shader debugging is not supported for this GPU. Do I need to install a debug driver, perhaps? Maybe that would fix it. Because I would like to, but maybe this GPU just can't do it. So it looks like they maybe just don't support modern GPUs with shader debugging. Like shader debugging just went away. Which I guess that's just like kind of a feature regression maybe. Because we are using the latest version, so I don't think it's a question of having to update Nsight. I guess it's just Nsight, their GPUs no longer support shader debugging, I guess. That would be bad because we want them to go towards supporting shader debugging. If they actually support less shader debugging on this than they did on the old series, that would be bad. But I'm not sure. Let me just double check. Just wanted to make sure that there isn't a different version of the driver that you have to install. I don't know. So I'm not sure why that is. We'd have to ask someone at NVIDIA, I guess, whether or not we're supposed to be able to do that, or whether like you just can't debug shaders anymore. You have to go buy an older graphics card in order to debug a shader. I have no idea. However, for the time being anyway, we will not be able to do that, so that's fine. If we wanted to do something, I don't know, like if we wanted to take a quick moment to try and display some more debug information here, one of the things I'm going to do is I'm going to get rid of this to see if we ever get into that light loop anywhere. I mean, it looks like we don't, right? No matter where we're sort of pinging. I also, we need to get rid of that debug. Like our voxel is shrunk down quite a bit from what it, or is compressed. way more than it should be because of this bounding solid that we're sending down there. And I really don't want that to be included in the solution. So that's like kind of a bit of an issue there. Let me see if I can just get rid of that really quickly as well, so we don't have to contend with it. So here's push volume outline, push direct outline, all of these. I'm going to get rid of all of those. And so now we shouldn't have anything off in the distance there. We don't. So we should just be dealing with just this segment. Right? Okay. So now in here where we're looking up into the light index, and we're doing our textile fetch into our lookup sampler, we're never getting a valid value out of it, which is kind of nuts. I'm going to go ahead and not even try to do the integer casting. I'm going to actually convert this down to just do like, look, here's a light I value. Let's just actually take whatever we get and make that be the use light C. So I'm going to do a textile fetch into the lookup sampler at Voxi. In fact, I'm just going to draw this directly. I won't even do that. I'll just do world p minus vox min corner. Like I'll just do a lookup at Voxi and see what I get if I just return it directly. Right? Because I don't really have any idea why we're having such a hard time pulling out of this texture, but we seem to be. So I'm just going to try and get something showing up anywhere on the screen at all. And that seems somehow almost impossible, but I don't know why. Because, we are sending down values for this thing, so I just don't know, don't know what exactly is happening there. So inside OpenGL, I also want to look at where we're submitting text subimage 3D here. And we're sending down unsigned shorts, which is what we would expect. So yeah, again, that just seems like that should work just fine, I would think. But we're just not getting anything, right? This is like, the graphics card isn't giving us any help here at all. If I wanted to look up into the voxel by a floating point value, I should be able to divide by... I should be able to take the vox I and turn it into a vox UV by dividing by the constant values, the light dimension X, the light dimension Y, and the light dimension Z, right? That should also, if I want to look up that way. I shouldn't have to do that though. I should be able to look up by integer values. So it's kind of weird that I would have to do that, but yeah. So yeah, I don't know. I don't know why we're not getting anything back. That seems really broken. Like, it seems like that should be clearly giving us something back. We looked and verified that there was something in it. However, one thing I will say is, even though there were clearly values in it, those values didn't seem to come out properly in the texture preview. Like when we looked at the image that the Nsight was showing, it didn't seem to actually ever show us valid data there. in the memory view it was, but in the actual render it wasn't. And I do wonder about that as well, because I'm not sure why that was going on. But now in this, these should be floating point values stored in here. So we should be able to get an RGB value out of it. And the fact that we're not getting any RGB out of it, no matter where we're looking, is just nuts, right? I don't understand what the problem is there. This is why I hate GPU programming, because, yeah, you get no information. It's all the worst aspects of debugging, once again, is because you have literally nothing to go on. It's like, who knows? And this stuff is all spec'd so poorly that it's like, all right, yeah, I don't know. Like, there's all these parameters you can specify, but hey, like, there's just a bunch we don't allow, and we don't tell you about that, so have fun. So, yeah, we need to figure out why we are not getting anything out of our lookup sampler. Because that's obviously the... we're just not getting anywhere until that thing gives us a valid result out for our voxel lookup. And in order to get that, I don't know what we should do. Like, I don't know how we can prod it any more than we're already prodding it. One thing I could do is start trying to look it up into it in some way that does not involve integer lookups. So I could try specifying, a manual lookup here that was going to just do a regular Texel call, right? So if I did texture and I ask it to use the lookup sampler and I pass it a vec3 here, maybe one that I've sort of pre-divided by the lighting value, the actual dimension values. So it's still 0 to 1 like a UV coordinate should be. See if that helps. I doubt it will. Nothing. So yeah, I really just do not know what it is objecting to there. I should probably have the game start up windowed now because Nsight doesn't work when the game is full screen. So it just saves a step there. I constantly have to remember to like Alt-Enter. So here's the lookup sampler. And again, we see no pixel data in it. However, if I switch to memory view, at least as before, we do see values in it. Part of the problem, I suppose, is that those values will just be very low because they're only representing like a tiny fraction of what we actually can specify in a float. And maybe we're just encoding those wrong. I don't know. So if they're a floating point value, let's see what it encoded here, for example. Let's find an area that's got some stuff in it. Really don't understand why there's so few of these, and yet we tried debugging the voxel, and it had actual, it seemed to store all the information just as we expected it to. Yet I just see so few entries here. Like, how is that possible? Right? It just seems like something's busted. Let me double check again. Something doesn't make a lot of sense, but I just don't know what it is. I guess the other thing I could do is I could manually force that voxel's data to be floating point. Like when we submit the texture, instead of submitting it as 16-bit values, I could just force it to be floating point, right? So this lookup here, so if I was going to do that, then when we create one of these guys, what I could do is say like, all right, yeah. When we write the lookup at value, in addition to writing it this way, like so, I'm also going to write it this way. So I'm just going to store a floating point value that's exactly the value that I actually wanted. No adulteration whatsoever. So I should just be able to see it directly in there, right? And then in the render group, where it goes to push that value on, we'll just say whatevs, you know, it's fine. So all I'm doing is sending down a completely parallel version here that I know has been unmolested to try and eliminate, I don't know, just something like OpenGL is screwing us here, and I don't really know exactly how. So, you know, I don't have any other options. So when you don't have any other options, you have to just start trying something to see if you can convince it to do something resembling anything. So if I go ahead and do a text subimage here, and instead of doing it this way, I actually do it the opposite way. So I say, you know, I'm sending GL floats down. Here you go. And then when we look at here, we do the same. And I don't know that we actually need to do that because we're not submitting anything here, but hey. So now we've got a floating point texture that should have values stored in it. When I actually go to do the F1 here, now what I'm expecting, oh, I forgot to do the start graphics debugging. Now what I'm expecting is if I go look at those values, they will actually be even indices into the array as I wanted them to be. So I hit F1, I pause and capture frame. Ah, crap. And I forgot to unwindow ourselves. Boy. I hate programming GPUs so much. Why did I ever let myself get talked into this? All right. So let's try that one more time. Yeah. That time we worked. Here's the texture. I'm not sure what happened there. So now it doesn't think we submitted it at all. Did I not actually, maybe I didn't hit F1. Let's hope that's the case. I forgot to, okay. Just shoot me now. Just really put me out of my misery. All right. So basically I've hit that problem enough times. I'm just going to go switch us to not be windowed by default. Because it just takes, there's just too many steps and I forget to do them all. There we go. So F1, and now I can do it. All right. So in theory now we shouldn't have that problem anymore because we'll start regular windowed, so I can't forget to hit the Alt-Enter key before doing the little magical dance to actually get the debugger to sort of do something resembling anything. So we still wait a little bit. How are we doing here? There we go. So if I don't need this window open yet, but thank you. If I take a look at where that texture ended up, here's the lookup sampler. All right. So now we can actually see the voxel, right? And it's populated. So I don't know. I'm going to stick with this then because at least we can see it, which is nice. And if I go in here to like a volume slice, I should see some values somewhere, I would think. Of course, I don't. Shouldn't I be able to... How do I get out of this volume slice? Hello? Is there some way to control which slice I'm looking at here? Oh boy. So it doesn't correspond to that because this says volume slice 19. Like, shouldn't there be a thing that lets me flip through there or something? I don't really care about that. All I want to do is get back to the screen I was just on, but that seems like it doesn't want me to do that. Is it just me? Like, am I just like crazy or something? Like, how does this stuff even end up this way? So there's got to be a way to get back to it, like, that doesn't involve that, I would assume. So when I click in here, there must be a way to get back to the previous thing. Okay, so I right click in the white area. Looks like the magic. Sweet, merciful baby Jesus. All right, so if I come down here and look at this like volume slice 19, I see a bunch of values in here, but they're all just bright red, which also doesn't super thrill me. I mean, that doesn't sound particularly good. So that's volume slice 19. Look at all those values there. Now I come over here and I say, let me see volume slice 19. I should see a ton of values, right? Okay, good. There we go. I'm like, it shouldn't be impossible to see this. So all of these values are good, right? That's exactly what I want to see. So that's fantastic. Like, I am a happy camper about that. That's very good. So let's now take a look and see if there's anything I can do to prod to get, heaven forfend, get the GPU to actually read those values when we're actually doing some shading. I know this is a big ask, but here we go. So here we are in the ZBias program. I'm going to revert back to the previous path here to just see if I can pull a texel value out of there. Like so. All right. So when we do a texel fetch at a particular voxel location, we just verify that the values are actually usable directly. So in theory, this texel fetch right here should return us an integer. It's in a floating point value, but it is actually just the integer we wanted. So we should be able to just go ahead and use it directly as an integer, right? We can then go ahead and test this part of the loop and see if we ever get anything that's not 0, right? Here we go. And magically, we still get nothing. I have no idea how that's possible, right? None whatsoever. Because we're searching over a fairly wide area, unless this math is wrong, maybe it is. When we're doing this texel fetch, we should get those values out somewhere, right? We should get those values out somewhere, but we don't actually seem to. So I have no idea why. Literally none whatsoever. So inside here where we're saying the IVEC3, one thing I could do here is, again, let's try to debug this value just to make sure that maybe we're using a valid lookup of some kind. So I'm going to try to make the Vox UV value here. I'm going to set use light I'm going to set use light C to actually just be equal to the Vox UV for now, so we can actually see where we're looking up in the voxel directly as best we can. So I'm going to take Vox P and I'm going to multiply it by 1 over each of our dimensions. So you can see in here, all right, we've got this voxel position. This is going to come out as like a 0 to 256, 0 to 256, 0 to 32, assuming that we did this math correctly. I'm going to change that to what I think is a UV by just dividing by what I think the size of the texture we're looking up in is. We don't care about the rest of this because we're ignoring it right now. In fact, this, and this are all superfluous now. So all we're going to do is just draw that UV value. Right? That's all I want to do. So here we go. This is the UV values that we're drawing. They don't look correct to me at all, so I guess that's good information. They're not totally bogus, but they are somewhat bogus. So what should be happening is we should be getting a gradual increase in green, a gradual increase in red, a gradual increase in blue, and we're sort of getting that over here, but it tops out too quickly. So it looks like I've done something stupid with respect to how I'm computing the voxel position, or something like that, right? Like the voxel's not aligned properly, or something like that. So I want to take a quick look. I know it's time for questions, but I want to take a quick look and see what's going on there and verify that I don't have something really dumb going on. All right, so let me just make sure that I've got those values correct. You can see it's 2d6, 2d6, 32. So there's 2d6, 2d6, 32. So in theory, right, we should always be getting something between 0 and 1 for all of these voxels, assuming that the min corner is actually where we think it is, and the inverse cell dim is actually where we think it is, right? So yeah, I could also do something else here. Ooh. So I'm trying to think, but another thing that I could do here is I could just try to do an if statement and set the light C equal to a certain value in either case. So what I could do is do like, it's black everywhere that it's in, but if, you know, vox uvx is less than 0, or vox uvy is less than 0, or vox uvz is less than 0, or vox uvx is greater than 1. You get the idea. So basically what I'm going to do is I'm just doing a bounds check here, and I'm going to set the color to be red everywhere that it's outside the voxel, right? Just so I can check my sanity. So it does not appear to be here, right? So I'm not sure why we were getting such an odd color ramp. I don't know if that's because of some kind of gamma correction that's happening there. I don't know why we were getting such a weird color ramp there necessarily. It's a little troubling. Because if we're never outside the voxel, then we should have been getting something fairly stable there. And it didn't look like we really were. So that's a bit odd and probably warrants some further inspection. But yeah, so the next thing I'm going to do is I'm going to change it to slightly inside the voxel, so I can see whether or not we're actually properly getting the bounds to be. So I moved the voxel boundary in by about 1/4. All right, and so I'm still not seeing any of that. So this is just bogus, right? Our Vox UV value, oh, that's great. Or I just did the test wrong. All right. So our Vox UV is wrong. It's always hitting that case. And you can see there's a little bit of it that's inside the voxel, and most of it is outside the voxel. So it looks like we've got a voxel alignment problem here. Something we're doing to try and create the UV values is incorrect. Right. So this vox p, you know, I guess I can try to start debugging this a little bit more, pushing it up a bit. So vox p, we know what that should be as well, right? That should be just this, because we know the dimensions of our voxel, and so we know what we think that should be as well. So as soon as it exceeds those values, we know that something has gone wrong. Really, it's actually, for being specific, it's actually that, because it can't even hit, it can't hit 256 either. That would be bad. So here we go and running it. So that actually looks correct. That's roughly what we would expect to see. It looks like our voxel needs a little bit more room there on the side to give it some error tolerance, but otherwise our voxel looks to be fit properly. So this line was wrong. This vox UV was incorrect somehow. However, I can't say that I see how at the moment. That should have worked, right? If we know the value is between 0 and 256, and then we divide it by 256, we should get a number between 0 and 1. That seems like an uncontroversial statement. So I'm not sure why the UV test was failing in such an odd way. It looks like the UV was never really getting divided by that number. And I don't know why. We don't need that value in the computations. That's okay. I'm going to move on to the next one for now. If we take a look at vox I, we should now be able to look at the values as integers and verify that the same thing is happening. And it is. So I don't know, our voxel lookup looks really solid there. That looks like it's looking up into exactly the correct place. I do not understand what it is having a problem with. So I have no idea why this textile fetch is failing. That looks like a very reasonable thing to pass to the fetch, yet the fetch seems never to produce a value of any kind. And I have no idea why, right? I do not know why our textile fetch always produces 0, no matter what we do. So I guess that'll be the puzzle for next weekend. For now, I'll go to a brief Q&A. So anybody who has a question can put it in now. All right, so insofar as says try using glred integer instead of glred, I am totally down with that as an attempt to get it to use integers. So here's where we are storing this value out, right? And the problem is that if we change this to an R16 UI and leave this as it is, it got very angry with me, right? here's where that call was happening, right here. So the question is, well, can we change it to something else and have it work? So if we were doing this, which I think is what, and insofar as I think was suggesting that we pass red integer, will it work? We need red integer to be defined, which we don't have at the moment. Here it is. Oops. And hey, all right. Thank you, insofar as. I mean, I would just like to take a moment to say again how ridiculous that kind of thing is. Like, that is just nuts. Like, why would you hang up a programmer on something like that? There's no reason for API design of that nature. It's just kind of inexcusable. I mean, it doesn't even make sense. But, off you go. Anyway, so let's go ahead and fix the text subimage call as well then, because that's all we needed there. Insofar as saves the day. Insofar as, by the way, is the famous author of Insobot, who you may have seen on the chat. It's basically, I mean, there's a lot of talk in Silicon Valley these days about artificial intelligence and cloud computing and all these sorts of things. But basically, Insobot is the embodiment of all those things. It is not only cloud computing artificial intelligence, but it's so far ahead of anything they've got in Silicon Valley, it's ridiculous. Like, Insobot makes Alexa and Siri and Google's whatever voice thing just look like such a joke. It's not even funny. I mean, it comes up with the best witticisms. Anyway, let's take a look here and see if there's anything else I need to do. I think that's it. So I would just specify the regular lookup pointer here, and I should get those values out. Let's take a look. Yep. So now I am specifying integer textures, finally, and that is very good. I also need to go specify when I get those values out. Now I think I can use a uSampler in theory. Of course, we weren't getting anything out of the other sampler either, so I'm not sure that it necessarily matters yet, but what are you going to do? So let's just set that back to what it was supposed to be set to. All right, so zbias program. Zip down here. There's our lookup sampler. I'm going to set that to uSampler 3D. And in here, as we go, we want to see if we can get this to sample directly. Well, almost. I always cast the wrong way. Never going to remember that. There we go. Perfect. So we haven't debugged our stuff at all, but at least we can say that thanks to Insofaras's suggestion, we are able to get OpenGL to stop complaining about us just wanting to store that texture in a more sensible format. than floating point, which takes up twice the space for no actual benefit. Let me go zip through the final questions here. Needs more 738. I totally agree. What do I think about GPU Open? I don't really know much about GPU Open. How much prep do you do before every episode? There's no prep for the episodes. The whole point of the episodes is actually to do the opposite of the normal thing, which is, you know, normally when you get like tutorials or programming things like that, you just see a programmer who already did all the work and then they just sort of walk through the result. So we try to do the opposite of that. So on some streams, if we're doing something easy, it may look like it was prepped ahead of time just because it happens to be easy. So there's really no struggle involved with it. But other times, like for example, this episode, you know, it's something that's, you know, kind of API nightmare stuff. You will see me do all the stuff I normally have to do in my day job, where I'm just like, I don't know why this is black, and here I go poking a bunch of really simple tests in just to try and find, you know, what OpenGL doesn't like or what the GPU doesn't like, and so on. TTBJM. I'm curious if fixing the WM message bug also fixed the crash in RenderDoc. I can test that if you want. Oh, so eventually they will support shader debugging in Maxwell and Pascal. So they didn't like remove it from the hardware or something. It's still possible to do. They just don't have software support for it or something. Bleeding Egg. Hi, Casey. My experience is very good for developing GSL to keep shaders in files and have the software automatically reload them if they're changed. Yeah, I agree with that, and I avoided doing that originally because I didn't think we were going to be doing anything fancy. Turns out we did end up doing some fancy things, so I wouldn't necessarily be adverse to going that route now. So we'll see. All right. So let me quickly just capture this here. Barishu, off topic, so it's okay if you're in a hurry. Do you have any experience with rendering impossible spaces like an antechamber or the secret levels of Duke Nukem 3D? No, I've never really done anything along those lines. You could probably include in that, like what they did for Portal, for example, would be another example of that. I mean, there's usually not a whole lot to it. It usually boils down mostly to sort of doing recursive rendering, where you render from one perspective, then you composite that into a rendering from another perspective, and you composite that into a rendering from another perspective, right? So you just like rendering repeated renders that all like pick a different camera point, you know, and there isn't, you know, sometimes there's more to it than that, but usually that's the basic idea, right? If that makes sense. So here is our integer image. I don't know how to verify that we actually have values here because it's always so sparse, but there they are. Right? And they look pretty good. I mean, that looks like it's working, right? So, all right. So I'm going to go ahead and close down. And I will also just, because someone was asking about it, I'll check to see whether RenderDoc can debug now. So here we go, launching. And this is with the 738 bug fixed. So here is, what we would want to capture. I hit F12. It's working on it. It's done. I've closed the application, and now it's doing its thing. I can't imagine why fixing the 738 bug would help RenderDoc, because it's not running my application anymore. So I don't know why that would matter. And the answer is no. It's totally froze again. Oh, well, that's better than it was. Sort of. I mean, it's still pretty not usable. I mean, it's so slow. It doesn't seem to be... No, it's pretty bad. I think we just have too many draw calls, maybe. Remember, we can simplify our draw calls a lot by atlasing our textures, and maybe we would need to do that if we wanted to use RenderDoc. I'm not sure. But no, I mean, I can't even close it, right? So I don't think that really had anything to do with it, because it doesn't run our application during that time, so I'm not sure why the 738 bug would even be relevant to it. Anyway. Thank you everyone for joining me for the episode of Handmade Hero. It's been a pleasure coding with you as always. If you would like to follow the series at home, you can always pre-order the game on handmadehero.org, and it comes with a source code, which I update after every programming session. That's about it for today. I'll be back next weekend for a little more coding. Hopefully we can figure out why the graphics card refuses to look up into that texture, and from there we can maybe start playing with our lighting a little bit more, which is what I would like to do. Until next time, take it easy, and I'll see everyone on the internet. Take it easy, everyone.